Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's see how you did on yesterday's homework. I'm going to take, let me do, well, they read. Okay, so it says Jessica's parents are planning their new house. They received a scale drawing from an architect, and Jessica is trying to figure out how big her bedroom will be. The architect has noted that each 1/4 of an inch on his drawing represents 1 foot of distance in real life in the new house. So here's the scale. One thing to consider is that the drawing, it's like a 1/4 to 1 sort of a ratio, but this is inches and that's feet. So you could actually say 1 inch, which would be 4 of these, is equivalent to 4 feet. That would be another way of putting it. So 4 feet is equivalent to 1 inch. So, however you want to think about that, this number is 1/4 of that number is 4 times this number. Forget about the unit of measurement as we're doing the math. So if the diagram of Jessica's room measures 2.5 inches by 4.5 inches, what will the actual dimensions of the room be? Okay, so maybe I will stick with this and say there are 4 quarters in every 1 foot, correct? 4 1/4 inches. And so we could say that would be 2 feet is the same as 1/2 of an inch, correct? So you double that, you double this, 1/4 of an inch doubled is 1/2 of an inch. So how many halves could you fit into 2.5? I think there's 2, 4, there's 5 of them. So you could take 5 times 2, and that's going to give you your measurement there. Or if you just want to stick with the original scale, how many quarters can you fit into 1 foot? You can fit 4 of them. So you're going to be able to fit a total of 8 quarters into the 2 inches, and then another 2 more for a total of 10 of them. So 10 of these, 10 1/4 fit into 2.5. So that means that 2.5 inches on the diagram, on the picture, is going to be 10 feet in real life. And then the same thing applies here, where it's just how many 1/4 can you fit into 4 1/4? Well, you can fit 4 of them into 1, so you'll fit 16 of them into 4, plus another 1 for 4 1/4. So that ends up being 17. So the dimensions of Jessica's room end up being 10 feet by 17 feet. Now you could also set this up if you wanted to by using proportional reasoning. So you get your feet for the real distance on the top and the inches of the diagrams on the bottom. And this is the scale factor, this ratio, and this is the known measure. So what do you multiply times 1/4 to give you 2.5? That's the 10 that we showed right there. So 1 times 10 is equal to 10 feet. Same thing applies here. How many 1/4 fit into 4 1/4? 17 of them. So 17 times 1 equals 17. So a few different approaches you can take, which is just really important that you understand the logic of how we can convert from one unit of measurement to another and how we use scale. All right, Stuart is a plumber working at Garcia family's house. He's working with PVC pipe. So here's a rendition of PVC pipe. And the internal diameter, as you can see from here, from top to bottom, from side to side, is 3/4 of an inch. The thickness of the pipe is 3/16 of an inch. So what's the external or exterior diameter? How far is it to get from here all the way to here? Well, what are we going to have to add up? You're going to have to add up this one, or this 3/16 plus this 3/16 plus this is 3/4. So that's what I've got written right there. We're going to have to add those numbers together. So in order to add them together, we should get common denominators. So 16 looks like the common denominator. When we multiply this times 4/4, that's going to give us 12/16 plus 3/16 plus 3/16 again gives us a total of 15, 16, 17, 18 16ths inches. Well, let's change that to an improper, or into a mixed number. How many 16 goes into 18? Only 1, and you've got 2 16ths left over. and then that fraction can be simplified, and that's how we get the diameter, total diameter of the outside of this PVC pipe being 1 1/8 inches. Quintrell has written, or is writing a Guess My Number game. He decided to write the clues in a different way. He wrote, when 35 is added to my number, and remember, my number is the mystery number, so that's your variable, that's your x. So when you add 35 to x, the answer is 4 times my original number, which was x again, so 4x plus 8. Well, you could do guess and check with this, but it might take a little while. Why not just solve it algebraically? Remember, we're going to remove balanced sets, take the same away from each side, and do it strategically so you get the x's away from one side and only on the other side. So if I take away these x's here, that makes a 0 pair, leaving you with just the 35 on the left-hand side because you took away the x. But you've also got to take away an x from the right side because you got to do the same thing on both sides of the equation. That's the removal of balanced sets. So you had 4 x's, you took away 1, now you've only got 3 x's, but you still have that 8 over there. All right, so we're one step closer to figuring out what x is. Now, let's keep our x's over here, but let's get them all alone. So let's take away this 8. So remember, removal of balanced sets means whatever you do to one side of the equation, do the same thing to the other. Take away this 8 here, so you only have the 3 x's on the right side, and you took away 8 of the 35, which leaves you with 27. So now, 3 times our mystery number gives us 27 for an answer. Well, if we take 27 and divide it by 3, that will tell us what our number is. 27 divided by 3 is 9, so it means that 1x must be 9, and that is indeed the number that Quintrell started with. And of course, we want to check it just to make sure. So let's say, is 9 plus 35, what is that equal to? 44. And now what is 4 times 9? 4 times 9 is equal to 36. And then when you add an 8 to that, you also get 44. So yes, they're equal to each other. We can draw a box around that. Our answer is 9. M and N. These are unknown numbers, but they're integers, okay? So I guess it's presumed. We don't know if M or N are positive numbers. It doesn't really matter, but we do know that when you have a negative sign or a minus sign attached to either one of these variables, that means to take the opposite of it. So if we were to just assume that M and N are positive integers, then this has to be a negative quantity, because you're taking a negative divided by positive, which means you always get a negative answer. This particular problem is slightly different. If this one were to say the opposite of M divided by N, this says the opposite of whatever M divided by N is. And let's say, let's just pretend M is equal to 4 and N is equal to 2. So we get this one would be negative 2, right? Well, this would be the opposite of 2, which is still negative 2. So that means that these two are equivalent to each other. This would be negative 4 divided by negative 2. Two negatives, when you're multiplying or dividing, always give you a positive answer. So this is going to be positive 2, not negative 2. And then here you're taking like 4 divided by negative 2. A positive divided by negative will give you a negative answer. So this is also going to be a negative value. So it looks like A, B, and D are all equivalent to each other because they're all going to eventually give you, with these not imaginary numbers, but with just making up 2 random numbers, they all give you the same value. So they're equivalent to each other. And then a positive divided by positive gives you a positive answer. So it looks like C and E are also equivalent to each other. This particular problem, I often get students asking me, does it matter whether you put the negative on the outside of the fraction or whether you attach it to the numerator or the denominator? And I would say, no, it does not make any difference at all. No one ever really does it this way, but I do it this way all the time. And sometimes you'll see it like this as well. So either of those are fine. They're all the same thing. All right, 2 has a bag with 7 green marbles, 5 blue marbles, and 4 red, for a total of 12, 13, 14, 15, 12. Isn't that 16? Why do I have 18? Uh-oh, I'm going to pause. Hold on. My bad. All right, so sorry about that. Okay, so there are a total of 16 marbles. So probability is the number of desired outcomes over the total number of outcomes. So if there's 4 red marbles in this bag, and there are 16 total, then your probability is 4 out of 16, which simplifies down to 1/4. Red or green. So there are a total of 4 red and 7 green. So if you pull either one of those, that's a winner. So you've got a total of 11 winners there. So 11 desired outcomes out of 16. That fraction's already in simplest form. And 0 orange. There are no orange marbles in there, so it's impossible to get an orange marble. That would be 0 out of 16. All right, so hope you did well on this homework. Today we're going to do our next lesson, or are we? No, we're not going to do a lesson today. Today we're going to do a check for understanding, and I'll probably throw some Khan Academy videos out there for a little bit of extra support in how you find the area of circles. All right, take care.
Hey, feeling